Next topic we're going to talk about is what we call the slope of a line. You notice that in all of the equations that we worked so far, some lines look like this, some of them look like this, some of them look like this, and so on. And you can describe how that line looks by the slope. It's exactly what it sounds like. It's like going up a mountain. A steeper mountain has a steeper slope, and a really flat, piece of highway or something has a very shallow slope. And we're going to use algebra to mathematically describe slope. What I'm going to do is I'm going to give you an equation to find the slope when you know 2 points on a line. So let's say you have a slope, 2 points like this. 1, 3, that's 1 point, and 2, 4. Now we could draw a graph and we could plot those points and we could get the line. But I'm going to define what I call the slope. The slope is also, for some reason, I don't understand why, but for some reason they use the letter M to describe slope. What it is it's what we call y2 minus y1 over x2 minus x1. The only reason I wrote this equation on the board like this, in this method, in this way, is because that's how it's written in the books. It's a very simple equation to understand, so don't let these little numbers fool you. All you have to do is you have to take, remember this is x comma y, you have to take the two y values and subtract them, and then the two x values and subtract them, and that's all you have to do. So let's do that for a second. Okay, let's take y2, I'm going to say 4 minus 3 over 2 minus 1. 4 minus 3 is 1, 2 minus 1 is 1, so the slope of this thing is 1. Okay, the slope of that thing is 1. Now, really, I'll just take a brief minute to explain why we're doing this, because it is kind of interesting. You have some line here, okay? It has a certain slope. In order to characterize the slope, you need to know how fast is the thing going up compared to how fast is it going over. Because obviously, if it's going up really steeply, it's going to be moving up really fast compared to how it's moving over. And if it's really shallow, it's going to be moving up very slowly as it's moving over to the right. So what you're doing here is you're taking the two points on your line. Let's say 1 point was here and 1 point was here. You're taking the y value and you're subtracting them, and you're getting this distance right here. And that's how fast it goes up. And then you're taking the two x values right here and you're subtracting them here. Okay? And that's how far it moves over. And you're dividing these two numbers together, and you're coming up with kind of like a measurement of how fast it's moving up as compared to how fast it's moving over. Another really convenient way to remember this formula, M is equal to rise over run. How fast does the line go up, rise? How fast does it go over, to run? The only thing you need to be careful about when you do this, you can subtract the y values in any order that you want, as long as you do it consistently. And what I mean by that is the following. Let me just give you a quick example of what I'm talking about there. Okay, in this case we went 4 minus 3 on the top and 2 minus 1 on the bottom. You can also do it the other way, going this way. 3 minus 4, okay, and then 1 minus 2. Let's see what we get. 3 minus 4 is negative 1. 1 minus 2 is negative 1. Negative 1 divided by negative 1 is 1. You get the same value. It doesn't matter if you start subtracting 3 minus 4 from this point, subtract to this point, as long as you do it the same on the x. Again, you can go the other way. 4 minus 3 as long as you make it 2 minus 1. You just have to make sure that whichever point you're starting from, you start from the same way when you subtract on the bottom. So if you go from this point, subtract these numbers, that's fine, do it that way. But if you start at this point, subtract these numbers, that's fine, you can do it that way, as long as you're consistent. Okay? So that's the slope of, that's really the slope of a line. You just need 2 points to define a slope. We can just do a couple of additional problems. What if you had 0, negative 5, and 4, 3. Again, it's equal to rise over run. So you got to subtract the y values and then the x values. So I'm going to do it this way. I'm going to say 3 minus negative 5 over, and I went this way, 4 minus 0. So I've got to go the same way. 3 minus negative 5, 4 minus 0. I've got to go the same way. Anytime you have minus a negative number, it's kind of like adding the opposite. So you can put pluses there. Okay? So 3 plus 5 is 8. 4 minus 0 is 4. So the slope is just equal to 2. Okay? Okay, another problem. Let's say we have 2 comma 3 and negative 3 comma 2. Okay, so I could say m is equal to 2 minus 3 over negative 3 minus 2, negative 3 minus 2. 2 minus 3 is negative 1. Negative 3 minus 2 is negative 5. So then when you do this, negative over negative is always positive, so you just get 1 over 5. Okay? Most of the time, when you find the slope of something, it's going to be a fraction. Okay? Most of the time it is. And all this fraction means is that, remember, it's rise over run. Rise over run. Okay? So what that means is, every time I go up, I go over 5 times. So you can kind of think of it that way. Every time I go up 1 unit, I go over to the right 5 units. And that's exactly what the slope is really just trying to convey. It's just a fraction, you know. And sometimes whenever there's no explicit fraction there, if the slope is just equal to like 2, never forget that all numbers can be written with a 1 on the bottom. So like if you have a slope of 2, well, that's just equal to 2 over 1. Okay? So the rise would be 2, the run would be 1. Okay? So that's how that goes. So really, the slope is really always a fraction if you think about it. And we can do one with a little bit more negative numbers just for practice. Negative 5 comma negative 7 and negative 4 comma negative 7. Okay? So I can say that m is equal to, I'm going to go this way to this way, negative 7 minus negative 7 over negative 7 minus negative 7, negative 4 minus negative 5, negative 4 minus negative 5. Remember, anytime you subtract a negative number, it's like adding the opposite. I can do that. Negative 7 plus 7 is 0, because it's kind of like 7 minus 7. And then down here, negative 4 plus 5, kind of like 5 minus 4, is just 1. 0 over anything is just going to be 0. So the slope here is 0. And that's exactly what you think it would be. You know, if the slope of something is 0, it means, if this were a graph, it means there's no slope at all. I mean, it's flat, which would mean the slope would look something like that. That's something that has the slope of 0. Okay? As you start to have a line that goes up, 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 well, then the slope gets bigger and bigger. So slope of 2, a slope of 3, 4, 5, 6, 7, 8, 9. If it gets vertical, the slope gets extremely high, actually goes to infinity. Okay? So let's use what we've learned here and do a couple of different kinds of problems. Okay? Let's go ahead and just do some graphing. Okay? Let's say I have a point, 0, 3. That's a point on a line. And let's say also I know, for some reason or another, that the slope is equal to 1. I'm going to show you how you can graph that. First thing to do is put down the point you know. So I'm going to say this is 1, 2, 2, 3, 1, 2, 3. This point, 0, 1, 2, 3, is right here. Okay? So that's a point. All I need to know is one more point, and then I'll have this line defined and I can draw it. I don't have another point handy, but I do have the slope, which is very, very useful. Very, very useful. Remember, the slope is equal to rise over run. So remember that when a slope is equal to 1, it's kind of the same thing as 1 over 1, because that's equal to 1. So if I rise 1 unit, I run over to the right 1 unit. So I've got my second point. There's my line, just like that. With any time you have a slope and 1 point, you've got the line defined. Put your point down, pick up your slope, rise the number of units, run the number of units, and so on. And that's it. Let's do a couple more like this so you can kind of get the hang of it. Okay, we'll leave that off to the right just so you can remember things. But let's say you have a point like -3, 2 with a slope of 4, like that. If I wanted to draw that, first I've got to plot my point. I'm going to go -1, -2, -3, 1, 2. So I'm going to go plot this -1, -2, -3, 1, 2. Here's my point. The slope is 4, which remember is the same as 4 over 1, which means I rise 4 units, I run to the right 1 unit. So let me put a few more tick marks here, like this. Okay? I'm going to rise 4 units. 1, 2, 3, 4. I'm going to run 1 unit. So my line is going to look more like this. Okay? Because slope is 4, so 1, 2, 3, 4. 1, 2, 3, 4. And I just went to the right 1 unit. And then I've got my second line. Okay? Okay. Okay, we'll just do one more just to kind of solidify this. -1, 3, slope is equal to -5/3. I just picked that because the slope is more of a fraction. First thing, plot my point. Okay? This is -1. Remember, this is x and y. 1, 2, 3. This is -1, 1, 2, 3. Right? This is +1. So I go -1, 1, 2, 3. I'll put a point there. That's 1 point. Okay? I'm going to draw some more tick marks. This is 2, 3, 4. And remember, this is negative. So, in order to get my second point, I got to go down 5. 1, 2, 3, 4, 5 over 3. 1, 2, 3 is going to be right here. And I've got something that looks like this. Again, you have your point, you got to go down 5 because you're rising a -5. So instead of rising 5, you actually go down 5. 1, 2, 3, 4, 5. Over to the right, +3 units. 1, 2, 3. Easy enough, right? Okay. The final kind of problem we're going to do is kind of a different kind of graphing problem. Now we're going to explore equations of a line. I'm going to show you a trick, and this is going to be really, really useful. Remember when we were plotting equations of a line, like let's say we had 3x plus 3, and we had a couple different ways we could do this in the other chapter. We could make a table with points, plot them. We could also put a y-intercept and an x-intercept, put 0 in here and find what x is and all that stuff. Okay? Well, I'm going to let you in on a very useful thing to know, and that is when you're looking at an equation of a line like this, whatever is written in front of x, that is the slope. Okay? That's very, very, very useful to know. Very, very important. Okay? This is called the slope. This is called the y-intercept. Okay? And the reason it's called the y-intercept is because if you put x equals 0 in there, okay, if you put x equals 0 in there, you're going to get y equal 3. And remember, that's the definition of the y-intercept. If I put x equals 0 in here, then I get an intercept along the y-axis of 3. So I don't know where else the line goes, but I know it goes through that point right there. Okay? So if I want to graph this thing, I can do exactly that. I can take this y-intercept, I can put it on the y-axis like this. 1, 2, 3. Y-intercept is 3. and then I can just do the same thing I did before. I can continue up here with my labeling. This is 4, 5, 6, 7, 1, 2, 3. I've got a point. The slope is equal to 3, so I'm going to rise 1, 2, 3. I'm going to run to the right 1. So that's going to be my line right through that point right there. Okay? We went through that a little bit quickly, so let's just do some more examples. That's how you learn this stuff, is by just doing examples. Let's say I have another graph, another equation. 3x minus 2. Again, this number, negative 2, is the y-intercept. This number, 3, is the slope. It's as simple as that. You just read it right off of the thing. So if I have a plot like this, and I want to draw it, okay, my y-intercept I know is going to be a negative 2, because that's the definition of where the line crosses the y-axis. Okay, and I'm going to draw a few more tick marks here just to make it kind of clear. I'm not going to label every one of them, but I think by now you know this is positive and this is positive, negative, and negative. This is negative 1. So I've got 1 point defined at negative 2 along the y-axis. I just use my slope. I'm going to go up 3 units, 1, 2, 3, over 1 unit. I'm going to put a dot there. Now I've got 2 points, and this is my line. Okay? Not that bad at all, right? Let's say I have something a little bit different. Something that looks a little bit different, but really it's not that much different. Let's see if you can figure this out here. Let's say I had y is equal to x over 3. That's my equation. Usually I was telling you the y-intercept is what's kind of written off here to the side, the plus whatever, okay? But there's nothing there. So what do you use for your y-intercept? Well, when you think about it, you've always got plus 0 written out here. So your y-intercept is 0. So that means your y-intercept is right here, okay? Then you've got this to deal with, and you're like, well, geez, that looks a little bit different than the other ones. Well, you've got x over 3, but that's pretty much the same thing as 1/3 times x. I mean, think about it. 1/3 times x, I mean, I can just put the x on top. So that's x over 3. That's exactly what I have. So my slope is this, which is 1/3. Remember, it's rise over run, rise over run. So starting from here, I can go 1, that's my rise, 1, 2, 3, which is my run to the right. And I have an equation of a line here. Y is equal to x over 3. Okay? And finally, we'll just do one more problem to kind of solidify this y-intercept slope stuff. Okay, just to kind of make it even more clear in everybody's head. If I had an equation like 5/3 x plus 1/2, and I wanted to graph that, the y-intercept is here, the slope is here, it's 5/3, okay? So I'm going to put some tick marks here, and I'll put some tick marks here, okay? The y-intercept, if this is 1, 2, 3, the y-intercept is 1/2. So the y-intercept is actually in between there, like that. And my slope, I just put my y-intercept there, my slope is just 5 over 3, or is rise over run. So I'm going to go 5 units up, 1, 2, 3, 4, 5, 3 units over, 1, 2, 3. I've got my 2 points. That is the equation of that line. So anytime you have an equation of a line written like this with some number in front of x plus something, this is what we call the standard form of the equation of a line. All you need to do is you pull out your slope, you pull out your y-intercept, which is this number right here, put your y-intercept on the board, and then use your slope to kind of count up and over to get your second point. And it's kind of common sense that you only need 2 points to define a line. Once you have those 2 points, you draw your line, and you're done.